Hi, geometers. We are here looking at the most recent quiz you had, which is going to take some memory work on your part because you've had spring break. And so right before spring break, we had a 20 problem quiz, and I have gone through and chosen or identified the most missed questions. And I want to go over the 5 most missed questions in order. Well, actually, I don't want to go over them in order. I want to go over the 5 most missed questions with you. But 3 of them are all on a certain type of problem, and it's just like this one. And so I want to do these 3 last because we're going to go ahead and go back to this type of problem and do some more practice on it. So this problem, number 12, and it has a Venn diagram where you're not putting just the items in the Venn diagram, you're putting their probabilities in there. Number 13, exactly the same idea. Then we had number 11, which was the same thing. So those are 3 out of our 5. So we're going to end up with those. We're going to finish with those because I want to go into that topic a little bit more. So let's look at the other 2 of the top 5 most missed. This one says, let n be a randomly selected integer from 1 to 20. Okay, so I'm going to go ahead and I'm just going to write out the integers from 1 to 20. Now remember that integer means basically like whole number, except it can also be positive or negative. Well, it could be negative, in other words. Whole numbers are just positives and 0. So it's kind of like whole numbers plus the negatives is what integers are. But integers 1 to 20, they would all be positive anyway. So there are my integers 1 to 20. Now, find the probability that n is a prime number given that it has 2 digits. Okay, now in the directions I pointed out to you that 1 is considered can't be a prime number because the definition of prime number is a number that specifically has 2 factors and only 2 factors, meaning only 2 numbers can be multiplied to get you that number. And one of the 2 numbers is 1. Well, with 1, you don't have 2. It's just 1 times 1. So that doesn't count as prime. So the prime numbers are 2, 3, 4 is 2 times 2, 5 is just 1 times 5, 6 is 2 times 3, 7, 8 is not prime. Basically, none of the even numbers are prime after 2. Because after 2, every single even number can be written as 2 times some other number. So the other ones we have to check are odds. Well, that could be 3 times 3, so that's not prime. 11 is prime. 13 is prime. 15 could be written as 3 times 5, so that's not prime. 17 is prime, and 19 is prime. Okay, so find the probability that n is a prime number given that it has 2 digits. Given that it has 2 digits means we are only paying attention to the numbers that have 2 digits. So it's basically like we just narrowed our entire world down to what's in this sort of box with a little bump out here. Okay, so find the probability that n is prime given that it's inside this box, given that it has 2 digits. So we have 1, 2, 3, 4 prime numbers here. Out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So your answer is 4/11. Okay, now the other one that was also a most missed, but was not a Venn diagram like this, was a lot like number 19. Okay, let n be a randomly selected integer from 1 to 20. So we're going to go ahead and write out the sample space again. Anytime you're doing a problem that requires a little bit of thought, or even if you think it doesn't require a little bit of thought, but you have plenty of time, which you guys did on this quiz, it's worth drawing out the sample space if it's doable, if it's not like 100 items. Okay, if it's not going to take you very long to write out the sample space so that you have the visual in addition to just thinking it through, that's going to help. So find the probability that n is 5 given that is less than 8. So I'm going to go ahead and draw my little box around the less than 8s right now. Given that it is less than 8 means given that it's one of these numbers. 8 does not count because 8 is not less than 8. Okay, so the only numbers that count are 1 through 7. So I'm saying find the probability that n is 5, given that it's one of the digits 1 through 7. So 1 out of 7 is your answer. Now let's go ahead and talk about our special, and hang on, I'm sorry, I'm printing something so that we can get to that next. Our special little Venn diagram problems here. Let's go ahead and look at these. All right, so these are Venn diagrams where, excuse me, we're not trying to put the whole sample space in the Venn diagram. We're trying to put the probabilities representing the sample space in the Venn diagram. Okay, so basically, first off, let me do this. I don't want to mess up that drawing, but I want to show you what we're kind of thinking here. Okay, the probabilities of being in group A go in that circle, and the probability of being in group B goes in that circle. So it's like the probability of being in A, when they tell me that it's 0.32, that's like saying this is 0.32, this whole area, including the part that bleeds over into B. And when they tell me that the probability of B is 0.48, that means this whole area, including the part that bleeds over into A. So don't make the mistake of getting this information and saying, oh, that means that this is 0.32 and this is 0.48. Because some of that 0.32 is in that little part in the middle that's overlapping. And some of the 0.48 is in the middle part that's overlapping. So I have to use any other clue that I have to help me figure out what's in the overlapping part. And a lot of times that's the best information to figure out first, is what's in the overlapping part. So here's what they've given me. They've told me the probability of being in group A, given that we know it's in group B, is 0.25. Okay? Given that we know it's in group B means we know that it's in group B. So it has to be somewhere inside this circle. So they're saying, given that we know it's inside this circle, what is the probability it's in A? Well, that would be just this part here. That's 0.25. So this little part here, the overlap part, is 25% of this circle. Because the probability of being in this little part, if we know it's in this whole circle, is 0.25. So this little part here, the overlap, is 25% of circle B. If circle B is 0.48, then this part here must be 1/4 or 25% of 0.48, which is 0.12. And that means that the rest of the circle for probability of B is 0.48 minus 0.12, which is 0.36. So again, this is the probability of being in A if we know that it's in B. So that would be probability of A given B would be the probability of being in both of them, A and B, out of everything that's in B. So that's 0.12 on top and 0.48 on bottom. Okay, and this is an equation you can use. This is consistently true. So now I know, if I know that this part in here is 0.12, then I know that the rest of circle A is 0.32 minus 0.12, so that's 0.20. So now I can add up these three and figure out what's outside of that circle. So 0.20, 0.12, 0.36. Think of it like money. These are all two-digit decimals, basically. 20 cents and 12 cents is 32 cents. 36 cents, that's 68 cents. So altogether, this is 0.68. And if I subtract that from $1, 68 cents from $1, that leaves me 0.32 outside. Let's cross those out. So that's the first thing you have to do on these problems, is correctly analyze what's going on and put it in the Venn diagram. Okay, so now they've asked me, what is the probability of being in A or in B. Remember, union is or. Well, that's basically all of this put together. So 0.20 plus 0.12 plus 0.36. So it's pretty much what we just did to figure out this. In other words, the answer is 0.68. Number 13 counts on us correctly being able to finish the same Venn diagram. So everything we did to figure out these numbers here, including using this thought, we have to do again for number 13. Or we have to be able to do that because we have to be able to use it for number 13. So again, the probability of being in A, given that it's in B, is 25%. So 25% of B is also in A. So 0.12 is here. That means 0.36 is over here. It's exactly the same info because it's the same setup. Now, the question you were asked here is, what's the probability of not being in B? This is what this says. What is the probability of not B? That's what the apostrophe tells me. Probability of not being in B is everybody, I'm trying to find a good, that is outside the B circle. So the easiest way to figure that out is, we were told how many people were in the B circle, or what probability was of being in the B circle, and that's 0.48. So the probability of not being in the B circle is 0.52. Notice that this is the complement of this, and the probability of a set and the probability of its complement will always add up to 1. 0.48 plus 0.52 is 1. Because basically either it's in that set or it's not. There aren't any other possibilities. All right, last one in our most missed parade. Same exact Venn diagram. This one asks, what is the probability of being in A or in B? Oops, we already did or, didn't we? This is and. It's an intersection. The intersection is always and. Okay? So this is something we're actually going to spend some more time on this week, is going back over the and ones, because we've done a lot of or, but now we're going to do some more and. So the probability of being in both A and B, that's the intersection. That's this part right here in the middle. So that's 0.12, or 12% chance.